Hello everyone, welcome to Code is Good. In this video, we'll look into hash table, that what a hash table is, and we will implement using Java all the code that is used for implementing a hash table. This is also a very popular interview question. It is often tied up with hash map in Java and asked. So please be with me till the end of the video. I will try to clear all your doubts. A hash table is an abstract data type, which means that it does not dictate how the functions will be done. It will just tell that what needs to be done. Often, a hash table is implemented using an array. The array stands as the backing of the hash table, which stores all the information that a user wants. A hash table, it saves the data in its key value structure. The hash table, it maintains two partitions. One is a key, another is a value. The value, it is your actual data that you want to save, and key is the index at which your data is saved. So this array, it provides it has an index, and this index will point to the actual data. We may think that why hash table has come. Hash table has come for mostly for optimizing the retrieval work in our application. It does find the our values from the saved ones in big of one time. How it does that? We use a hash function. A hash function is used in which we provide a key, and this key will be converted into an integer by the hash function. This integer will be the index of the array, index of the array. And at this index, our actual data gets stored. So whenever if we want to pull the data, find any data from the saved one, we'll again give the key. It will calculate the direct index of the data that it is saved at. Hash table is also known as dictionary, map, and lookup table. These are synonymous. A hash table, it maps our key into integer using the hash function. Okay. If you're using a Java, then hash function is used in object.hashcode. Often what happens that in the given or backing array that where we are saving the data, we may have collisions because the flow is like this. Key, it is passed to a hash function, and this gives the index. It may happen that for two different or multiple keys, the same index can get calculated by the hash function. Okay, this is called collision, that at the same index multiple entries have come for save. A collision is not good for any hash table, so the lesser a collision can happen by our hash function is termed as a better hash function and a better hash table. If we have less collision and better load factor, then they together make a good hash table. Load factor I will explain in the coming slide. Hope this collision was clear to you. If you have any doubt, then please leave out a comment. A load factor, it tells that how full a hash table is. We have a array backed hash table. So this load factor, it will tell me that what is the percentage of the hash table or this array is full. It is calculated by the number of items saved in this array by the capacity of the array. This load factor, it decides when to resize the array backing the hash table. what happens, suppose if we decide that at when 75% of this array will get exhausted, then we will double the size of this array. This is called resizing. So we give load factor as 75. When 75 crosses, then we will resize it. We must choose a load factor very wisely because they can hamper a lot in our performance of the hash table. A low load factor will cause too many empty spaces in the array over here. If we have a high load factor, then this will increase the number of collision probability. Okay, so as of now, this was a theoretical part. Let's get into our IDE and code a simple hashing function which will demonstrate that how we save into a hash table and how we will retrieve the items from the hash table. Okay, so over here I have created one employee class over here which has three fields: ID, first name and last name, a constructor, and its getters, and a string method. So this is only a Pojo. Over here, this is a driver method for testing our hash table. The hash table, before we test it out, we have created some employees for demonstration purpose, that these will be the actual data that we want to save into a hash table and retrieve it from the hash table. Okay, so this simple hashing is the class where we will write all the code for saving our data and then retrieving it back from the hash table. As we know that in our hash table, we save in the form of key value. Just some time back we talked about. So the key is, as for now, for this example, I'm taking the last name of the employee and saving the complete employee object against it. Okay, so let's get into our hashing class and then implement all the put and get methods. So firstly, we have to create an array which will be backing the saving of hash table. So let's create it private employee, an array over here. Let's name it as hash table. Then create a constructor in which we will define the capacity of the hash table. Hash table. Suppose we are initializing it with a capacity of 10. Then we need to define a hash function. We know that we will be given a key, and using the hash function, we have to determine at what index we will be saving the object or data in the hash table. So let's define our hash function first. We'll make it private void hash function. And as we saw in the driver main class, that we are using the last name as our key. So let's give it a string parameter and then return. We'll write a very simple hash function. Suppose the length of, according to the length of the last name, we will be calculating the hash function, hash index. So key dot length we will modulus to the hash table dot length, whatever is the capacity, so that it does not overflow our backed array index. Okay, so we need a index, so its return type will be int. Now let's implement the put method, which will take the last name and the employee data to be saved. Okay, so this is our key. For saving into the hash table, we'll firstly calculate the hash index. This hash index is the index in the hash table on which we will save the employee. So this index will be given by the hash function, which will take our key. And sometime back also we talked that there could be a scenario where multiple objects, they get the same index. So in this case, we need to handle the collision. So if for handling the collision, we'll check if the hash table at the given hash index should not be null. If it is not null, that means some other object has already taken that place, and this is a collision situation. So we'll simply print it out that collision has occurred at index. This index is the hash index. We'll also provide the key so that we get to know that which key has done the collision. So we'll print the key. And if there's no collision, then we will save our data into the hash table. So hash table at the calculated hash index will save the employee. And that's it. This is the implementation for our put method. We have a print hash table method over here so that we can check that what all items after all the save we have done, after we have saved all these items, what all items got saved into the hash table. So we'll use streams for that. Arrays.stream, we'll stream the hash table in that, and for each system.out print all the. Also we have got a get. Suppose we want to retrieve anything from the hash table, then we got to have our get method. We need to return an employee because the employee is getting saved in the hash table. So for this, firstly we'll calculate the hash index. This hash index will be given by the hash function, which will take the key. Oops, we'll rename it to be key. Okay. Okay, and then simply return from the hash table at the calculated hash index. Okay, so this is our final implementation of the simple hashing. So let's run our code and check if it works. So we see that when it was adding all these 5 items, then it got a collision for Synado because it is having 7 characters which is already present in Gilmer. And if when we were iterating this entire hash table, then we see that only 4 of the items got saved and it rejected the Synoda. And then we were retrieving Gilmer, which got over here. Okay. Thank you for watching the video. Please subscribe and like our video to encourage our work. Thank you.